Yeah!
Each year, the world produces over 400,000 tons of beef jerky. A staggering volume. Enough to fill an entire city like Chicago with strips of flavorful meat that can last for months without refrigeration. So how are fresh cuts of beef transformed into a form of food that remains shelf-stable over time while still preserving its full flavor? That journey begins across the vast, arid grasslands of the Texas Panhandle, where beef cattle are raised over extended periods to develop firm muscle, the foundation of high-quality jerky. From there, they move into modern processing facilities where high-speed seasoning systems and controlled hot air drying chambers work in sync, turning lean cuts into rich, chewy strips of beef jerky. Today, join Agriculture Insight as we follow the journey behind a seemingly simple strip of meat that has become a widely loved protein snack. While Brazil holds more than 230 million cattle, a vast living reservoir, the United States takes a completely different approach. Not raising more, but transforming meat into value. Each year, over 200,000 tons of beef are dried and condensed into convenient jerky, traveling across interstate highways to convenience store shelves around the world. Few people realize that beef jerky is one of the oldest forms of portable protein, dating back more than 2,000 years, beginning when the Inca hung meat in the cold winds of the Andes. Since then, these small strips have moved through history, spreading across continents and becoming a globally consumed food. Beyond its historical value, these thin slices function as a compact biological energy source, where protein is concentrated to levels that can be up to 3 times higher than eggs and far exceed fresh meat, which still retains water. As a result, each strip becomes a refined form of energy, dense, efficient, and quickly absorbed by the body. And to turn those small strips of meat into a massive multi-billion-dollar industry, everything doesn't begin in factories. It starts on the farms. Right now, let's head to the Texas Panhandle, one of the largest beef-producing hubs in the United States, where each animal is not just raised but monitored like a mobile data point. Here, cattle don't simply grow, they emit signals. From movement patterns and daily feed intake to the slightest behavioral changes, everything is continuously recorded through chips and sensors, allowing control centers hundreds of kilometers away to track thousands of animals in near real time. Across grasslands stretching to the horizon, breeds like Angus and Hereford develop steadily before entering feedlots, the acceleration phase, where diets are no longer left to nature but are precisely calculated down to the gram. Ground corn, energy-rich byproducts, and trace minerals are mixed within minutes, yet enough to feed hundreds of cattle per batch. As feed trucks move along the troughs, rations are laid out in continuous lines, synchronizing feeding behavior across the herd and maintaining consistent daily weight gain. Interestingly, even what seems like waste, such as melon rinds or corn cobs, is recycled into usable energy. Every day, tons of byproducts are reintegrated into the system, reducing waste and optimizing costs. And when everything connects, what emerges is no longer traditional farming, but a vast, data-driven production system. After approximately 120 to 180 days of finishing, once each living data point reaches its optimal threshold, the journey doesn't stop. It shifts into the next phase: transportation. The cattle are guided through narrow, curved chutes that leverage their natural instincts, allowing them to move smoothly while minimizing stress before loading. Transport trucks are divided into multiple, ventilated compartments with anti-slip steel flooring to maintain stability over distances that can reach up to 500 kilometers. And just minutes after each trip, every compartment is thoroughly cleaned, ready to continue the next cycle. a continuous flow with virtually no downtime. Leaving the grasslands after a journey of hundreds of kilometers, the cattle enter the most critical stage of the production chain, the processing facility. Almost immediately, the carcass is transferred onto an industrial splitting line, where a high-speed saw, operating at up to around 3,000 revolutions per minute, precisely cuts along the spinal axis within seconds. From here, each half is separated and moved into subsequent stages of sorting, trimming, and processing, where every cut is directed towards specific uses across the entire production chain. As soon as it leaves the main processing area, the carcass is transferred to the cutting stage, where raw materials are specifically prepared for beef jerky production. Here, the meat is not cut randomly, but separated along the natural grain direction to preserve muscle structure, a key factor that directly influences shrinkage and shape during drying. First, muscle groups from the shoulder and upper chest are prioritized, as they contain long, relatively uniform fibers, forming the foundation for jerky pieces that retain a stable shape after drying. Next, selected portions from the hind leg, rich in natural collagen, are incorporated to create the characteristic chewy and elastic texture. At the same time, the meat is inspected for color and lean ratio to ensure freshness and consistency before moving on to fat trimming and marination in the next stage. At this transition point, the production line moves into the trimming stage, the quality shield of the entire beef jerky process. Trimming always begins with the removal of nearly all visible fat, because even a thin strip just a few millimeters thick can significantly shorten shelf life after drying. The reason lies in the fact that lipids in fat oxidize much faster than lean meat proteins, leading to rancid odors and reduced product quality. For this reason, workers carefully remove the white fat layers, while also eliminating coarse muscle bundles, large tendons, and dense connective tissues, to retain only the most structurally stable meat. At this stage alone, up to 15 to 20% of the initial mass may be removed, but in return, it creates the foundation for clean, chewy beef jerky that can be stored reliably for months. After trimming, the meat is fed into a multi-blade industrial slicer, where continuously rotating blades cut along the natural muscle grain, producing slices with a near gold standard thickness of 4 to 6 millimeters. This precise thickness allows the jerky to form clear fibers after drying, maintain a clean shape, and achieve the characteristic chewy texture without becoming overly dry or brittle. Following slicing, the meat strips may be rinsed and briefly blanched in hot water for about 1 minute to clean the surface, reduce microbial load, and slightly firm up the muscle fibers. However, this step depends on the production facility and is not mandatory in all beef jerky processing lines. After the removal of fat and tough connective tissues, the meat immediately enters the flavor locking stage, a critical step that defines each brand's identity. Inside vacuum tumblers, salt, sugar, pepper, garlic, and soy sauce penetrate deep into the muscle fibers within just 20 to 30 minutes, then building a rich flavor base before drying. It is at this stage that each producer holds its own secret formula. Jack Link's leans toward a bold, savory profile typical of classic American-style jerky, while Old Trapper stands out with its signature lightly sweet, smoky flavor. After seasoning, each batch of meat is placed into sealed stainless steel tumblers, rotating at dozens of revolutions per minute. This continuous motion ensures the marinade doesn't just coat the surface, but begins penetrating deep into the muscle fibers. The real game changer, however, lies in the mechanical needle tenderizing stage. Within just 5 to 10 seconds, hundreds of fine needles pierce the surface, creating pathways that allow the seasoning to reach deep inside the meat. Depending on the facility, the marination process may be repeated 1 or 2 more times, effectively forming a multi-layer flavor lock, so that by the time the meat enters the drying chamber, the richness is no longer just on the surface, but fully embedded within every fiber. After marination, the meat slices are not simply loaded into the dryer. They must be carefully arranged layer by layer, almost like a thermal map, to ensure each piece dries evenly down to the millimeter. The slices are spaced about 3–5 millimeters apart, allowing hot air to flow across the entire surface. Even a slight misalignment in a single tray can cause an entire batch of hundreds of kilograms to dry unevenly. Because inside an industrial dryer, air is the true chef behind beef jerky. In some production lines, instead of laying the meat on trays, the strips are hung vertically on stainless steel rods using metal hooks, allowing hot air to circulate evenly around both sides at the same time. Once the meat is neatly arranged on trays, the entire batch is transferred into the drying chamber. From that moment on, the meat never touches direct flame. Instead, it enters a tunnel of hot air, where temperature is precisely controlled down to each degree Celsius. Streams of air at 50 to 70 degrees Celsius continuously pass through every layer of meat for 6 to 10 hours, drawing moisture out from each muscle fiber. By the end of the process, the meat can lose up to 60% of its original weight, and it is at this point that fresh meat is truly transformed into beef jerky. After leaving the drying chamber, the jerky strips may retain their signature long form. However, in some brands such as Jack Link's, they continue through an industrial cutting system where the strips are processed within seconds into uniform snack-sized pieces of around 2 to 5 centimeters, ready to move onto high-speed packaging lines. After leaving the sizing stage, the beef jerky moves into the final packaging process. Here, each bag is inflated with clean air to maintain its shape before receiving the product. Within seconds, the jerky is filled in standardized portions of 30 to 50 grams per bag on high-speed packaging lines, while workers perform quick checks on color, dryness, and weight to ensure batch consistency. Immediately after, the bags are vacuumed and fully sealed, creating a stable environment that limits oxidation and preserves the product's characteristic flavor. This seemingly simple step acts as the final lock of the entire process, allowing the jerky to be stored for 6 to 9 months while maintaining its chewiness, aroma, and fibrous structure almost intact. The modern sheep industry no longer operates through small scattered flocks. In Australia, a country often described as the nation riding on the sheep's back, the total sheep population has reached 74.2 million, nearly 3 times the country's human population. Did you know that Anna Creek Station in South Australia is currently the largest livestock ranch in the world, covering more than 24,000 square kilometers, larger than the entire territory of Israel? Even more astonishing, many medium-sized family ranches in the Australian outback range from 20,000 to 100,000 hectares, where tens of thousands of sheep move daily across vast, arid grasslands, adapting to harsh environments and developing remarkable resilience. Thanks to a diet of protein-rich native grasses and mineral-dense drought-resistant shrubs, a lamb weighing about 4 kilograms at birth can grow rapidly to around 40 kilograms in just 6 months, ensuring a fast capital turnover cycle for farmers. But freedom does not mean a lack of control. From the moment they are born, every sheep is fitted with an RFID electronic ear tag, functioning as an identity card within the National Livestock Identification System, NLIS. This technology digitizes the animal's entire life cycle, allowing managers to trace its origin precisely, from farm to supermarket shelf, and even identify which pasture it grazed on at a specific time. However, all digital data, would become meaningless without the ability to physically coordinate thousands of animals in the field. Despite the rise of monitoring technology, the most critical operational link on the ground remains specialized herding dogs such as border collies and kelpies. Trained rigorously from a young age, these dogs can sprint at nearly 50 kilometers per hour, allowing them to cover more than 80 kilometers a day across harsh terrain. Rather than relying on barking or aggression, they employ a technique known as the eye. Locking their gaze while lowering their center of gravity to create psychological pressure, prompting the sheep to move faster as they sense the perceived threat. On the other hand, sheep do not always comply perfectly. Dominant rams or protective ewes sometimes stop and challenge the dog while guarding their lambs. In such cases, herding dogs do not attack or cause injury. Instead, they use rapid zigzag movements to disorient the animal, forcing stubborn individuals back into the flock. A properly trained herding dog can control a flock of up to 2,000 sheep across hundreds of hectares, performing work equivalent to at least 5 full-time workers. With maintenance costs only about 1/3 of an industrial drone system, these four-legged partners remain the most practical solution to Australia's agricultural labor shortage. A country where only about 2% of the population works in farming, yet manages some of the largest farms on Earth. In reality, vast land is only half of the success. On large-scale ranches, disease, deadly threats such as roundworms, pulpy kidney bacteria, and tetanus can wipe out an entire flock, with mortality rates reaching 100% if left uncontrolled. These pathogens often strike at the most vulnerable moments, when lambs are just beginning to graze, or when pregnant ewes have exhausted their energy carrying offspring, leaving their natural immune defenses dangerously weakened. For this reason, a rapid vaccination program begins as early as 4 weeks of age. Young lambs are placed into V-shaped cradles that gently tilt them onto their backs, a device designed to secure the body in a relaxed position, allowing handlers to perform injections with millimeter-level precision while minimizing stress. For adult sheep, the process shifts to narrow squeeze chutes that firmly secure the body. The primary tool at this stage is an automatic vaccination gun, capable of delivering continuous 2 milliliter doses without interruption. To withstand the scorching heat of the Australian outback, vaccines are carefully stored in insulated cooler bags, a crucial measure to prevent antigens from degrading before they can enter the animal's body. Every injection is aimed at strategic golden zones, the skin at the neck just behind the ear. This location is deliberately chosen because it is far from the most valuable meat cuts in the hindquarters and thighs. As a result, even if swelling occurs, the commercial value of the meat remains fully preserved when it eventually reaches supermarket shelves. In just 3 seconds, each sheep receives a biological insurance policy, ready to roam confidently across some of Australia's harshest pastures, transforming biological risk into a highly controlled, professional disease management system. When sheep reach 6 to 8 months of age, they undergo their first shearing, a milestone that marks maturity and the moment they shed their layer of white gold to begin a new economic cycle. From then on, this thick fleece is harvested once a year using specialized electric shearing clippers. The golden standard in this process is continuity. Shearers must guide the clipper blades close to the surface of the skin without ever passing over the same spot twice. This technique eliminates second cuts, tiny fragments of wool produced when the blade crosses an already shorn area. Even a small amount of these fibers can immediately downgrade an entire bale of wool, as they cannot be processed in the high-speed textile machines used in Italy or Japan. With exceptional skill, A professional shearer can process more than 200 sheep per day, meaning that roughly every 90 seconds, a 5-kilogram fleece is removed without injuring the animal's skin. If a minor scratch does occur, the shearer immediately applies a special antiseptic powder to stop bleeding and protect the sheep on the spot, ensuring the process remains both humane and safe. The premium fleece is then graded according to its micron measurement. With fiber diameters of only 13 to 18 micrometers, many times thinner than the outer layer of human skin, the wool is sorted, compressed into bales, and shipped to wool textile centers around the world. However, not every part of the fleece meets the standards required for high-end textile production. Instead of becoming waste, wool fibers that are too short, too dirty, or taken from the sheep's legs and belly are being transformed into an unexpected solution: wool compost, a natural fertilizer made from wool byproducts. At first glance, turning sheep wool into fertilizer may seem unusual, but biologically, it is actually a massive reservoir of nutrients. The key component is keratin, a highly durable protein containing 12 to 15% pure nitrogen, a concentration comparable to or even higher than many premium organic fertilizers on the market. This process of revival begins with piles of raw fleece freshly shorn from the sheep, still mixed with dust, dirt, and especially natural lanolin oil. First, workers loosen and separate the clumps of wool to ensure the material becomes as uniform as possible before entering the processing line. Next, the wool is fed into a specialized pelletizing machine. Inside the device, steel rollers compress the keratin fibers and push the material through small die holes, transforming the soft mass of wool into hard, uniform pellets within seconds. As the pellets exit the press, they drop into a metal tray below, where they are cooled and collected. In just about 1 minute, fibers that once seemed worthless are turned into thousands of compact organic fertilizer pellets, easy to transport and apply. The finished product is then packaged and distributed as a comprehensive soil improvement solution, thanks to its remarkable ability to absorb up to 20 times its own weight in water. Once buried in the soil, the pellets function as a slow-release nutrient source, gradually supplying nitrogen to crops while also retaining moisture in the soil through the natural fibrous structure of keratin. But the journey of sheep wool does not end in the compost pit. In many gardens, it is used in an even simpler and more direct way. Raw wool is spread across the soil surface as a natural biological mulch. This method requires almost no processing at all. After shearing, the wool is kept in large, intact patches and laid directly around the base of plants or across garden beds, typically at a thickness of about 3 to 5 centimeters. Unlike compressing wool into fertilizer pellets, this approach serves a different purpose: protecting the soil surface and stabilizing the environment around plant roots. Thanks to its hollow fiber structure, the wool layer acts as a natural insulator, helping keep root zones cooler in summer while reducing temperature shocks during cold nights. At the same time, the mulch blocks sunlight from reaching the soil surface, making it difficult for weed seeds to germinate in the first place. After 8 to 12 months, the wool fibers gradually break down and blend into the soil, transforming what was once a byproduct of the wool industry into organic matter that improves soil structure, aeration, and fertility. Meanwhile, the fleeces that meet quality standards move into a strict industrial processing chain to produce the renowned merino fiber, a premium material that accounts for up to 80% of Australia's total wool export value on the global market. At the factory, the process begins with wool grading and sorting. Freshly shorn fleeces are spread across long mesh sorting tables, where workers carefully inspect them and immediately remove coarser fibers from the belly, legs, or areas contaminated with straw and dirt. Once selected, the wool enters the scouring stage, an industrial washing system designed to thoroughly clean the fibers. Passing through a series of hot water baths, the wool masses are continuously agitated and transported by roller mechanisms, which remove soil, organic debris, and the natural lanolin oil that coats the surface of the fibers. After the fibers become clean and loosened, they move into the carding system. Here, enormous metal cylinders covered with millions of microscopic steel teeth rotate at high speed. Working simultaneously, these teeth separate, detangle, and align the fibers, transforming them into a thin, continuous sheet known as a wool web. Today, a modern carding machine can process 150 to 300 kilograms of wool per hour, hundreds of times faster than traditional hand combing methods. From this separated fiber layer, the process moves on to the combing stage. Rows of ultrafine metal combs continue to straighten the fibers and remove any remaining short strands. The result is long, uniform fiber bundles known as sliver, in which the wool fibers lie almost perfectly parallel, an essential factor that gives merino wool its exceptional softness and strength. From these even slivers, the production line moves into the spinning stage. The fiber bundles are stretched and twisted simultaneously by industrial spinning machines. Thousands of individual wool fibers are twisted together to form a complete yarn, with the level of twist precisely controlled to ensure the strength, elasticity, and thermal insulation that characterize merino fiber. If the highlands of the Middle East are considered the cradle of the premium cashmere goat, where harsh climates and wild grasslands have forged some of the softest coats on earth, then Europe and the US are the consumer sanctuaries, importing nearly $1 billion worth of goat products every year. Can you believe it? In Morocco, some goats climb trees like circus performers. They casually scale the tall branches of argan trees, gripping firmly with their nimble hooves, just to feast on the rich, oily argan fruits. This isn't a joke or a Photoshop trick, it's a unique survival instinct. When grass becomes scarce, goats literally climb trees to feed themselves. The sight of dozens of goats floating in the treetops across Morocco's arid southwest doesn't just astonish tourists, it has become a strange and iconic symbol of the region. Once dubbed a forgotten treasure, goats have accompanied humans for thousands of years, offering far more than their humble appearance suggests. Goat milk is twice as digestible as cow's milk, and cashmere wool is lighter and warmer than sheep wool, making goats a true source of premium nutrition and luxury fashion. And for these four-legged treasures to reach the world, their journey doesn't start in a factory. It begins with transport, meticulously designed as if safeguarding a luxury item. To enter the US, goat herds from Mexico must undergo a rigorous naturalization process, the first step in a quality control chain that stretches from the highlands all the way to the dinner table. Goats are herded from the highlands to collection stations, where they receive nutritional supplements, undergo health checks, and are closely monitored to ensure they meet the criteria for shipment. Next, they are sorted by age, weight, and physical condition to optimize their management, care, and transportation. On multi-level trucks, essentially mobile hotels, the goats travel in well-ventilated conditions, cushioned flooring, and spacious compartments. Each truck can carry up to 300 goats, evenly distributed across 3 to 4 tiers. Throughout the journey, drivers maintain a steady speed, follow animal welfare protocols, and stop every 2 to 3 hours so the goats can drink water and relax. The truck's interior temperature is carefully regulated to ensure the herd remains comfortable and stress-free during transit. After their remarkable border-crossing journey from Mexico, the goats arrive at some of the most advanced livestock farms in the U.S., where every aspect of life is engineered as a closed-loop ecosystem, operated under high-tech industrial standards. Here, life for the goats resembles a precise technological process. Pastures are automatically distributed, feed is finely ground and evenly portioned into clean troughs, ensuring neither excess nor shortage. Each pen functions as a specialized nutrition station, organized by age and physical condition. Their diets are further enhanced with concentrated feed and natural mineral supplements, all customized down to each individual animal. Thanks to this system, the goats consistently maintain peak physical condition, as if they had just stepped out of a laboratory. Under the warm, quiet roof of the barn, mother goats quietly go through labor, with attentive support from a team of experienced caretakers. Newborn kids, trembling in their silky, downy coats, are immediately moved to a special care area, a modern incubator with regulated temperature, fixed feeding schedules, and essential vitamin supplements. Here, a specialized team of technicians closely monitors each individual, ensuring optimal growth from the very first days. After just 2 to 3 weeks, the young goats begin nibbling on fresh grass, while the mothers are transferred to the milking area, following a standardized process. When mother goats enter their milk-producing stage, they are brought to a central area to begin the automated milking process, a procedure that demands absolute precision, as goats are naturally picky and easily stressed. Here, they move in an orderly manner into individual milking stalls, each designed to match their body size, ensuring they feel safe and relaxed. The technicians, silent, emotional coordinators, must work with utmost gentleness, handle each animal with flexibility, and constantly observe their behavior. Smart sensor-equipped milking machines adjust suction power to suit each goat's physical condition, preventing discomfort or pain. The entire process lasts only 5 to 7 minutes, just enough to collect milk efficiently without affecting the animal's health. The milk is then transferred through a sealed piping system into stainless steel tanks, where it is immediately cooled to 4 degrees Celsius to preserve its freshness and nutritional value. The journey of pure fresh milk continues in specialized tanker trucks, where advanced cooling systems keep it as fresh as the moment it was collected. Each trip can transport up to 5,000 liters of fresh milk to the processing plant. Once at the plant, the milk is pumped directly from the tanker into the central processing system. Here, it undergoes fine filtration, rapid pasteurization, and cooling to around 39 degrees Fahrenheit before moving on to the packaging line. What surprises many is that the entire process, from pumping, filtering, and pasteurizing to packaging, is carried out entirely by automated machinery. This production line can fill up to 8,000 bottles per hour with near-perfect precision. Each finished bottle is then labeled, sealed, and carefully inspected before leaving the factory. In addition to being bottled, goat's milk is also crafted into delicious artisanal cheeses. First, the milk is poured into large vats and combined with natural enzymes to begin the coagulation process. In a cool environment, the milk gradually thickens into a smooth, soft curd. Once it reaches the perfect set, it is transferred to specialized cutting machines, where rotating blades slice the curd into small, uniform pieces. This marks the first step in transforming fresh milk into flavorful cheeses rich in tradition. The cut goat curds are then cooked and gently stirred at around 46 degrees Celsius (150 degrees Celsius) for 30 minutes, depending on the cheese variety. The automated stirring system operates smoothly and delicately, allowing the curds to shrink and firm up while retaining their natural creaminess and gradually separating the whey without harsh agitation. Once the ideal consistency is reached, the whey is carefully drained, leaving moist, silky curds ready for molding and aging. After the whey is removed, the curds are salted directly on the surface. Beyond enhancing flavor and aiding preservation, salt helps regulate moisture, control microbial activity, and shape the unique character of each cheese. The mixture is then placed into molds, both to form the cheese wheels and to gently press out any remaining whey, creating a naturally firm, smooth texture without added agents. After molding, the cheese is aged in a cool room at 10 degrees Celsius for several days to several weeks, depending on the type and style. This stage allows the flavor to gradually develop and the texture to harmonize, reaching the desired maturity. And the journey doesn't end there. Some cheeses reach an entirely new level through fermentation with special mold cultures. The penicillium mold is carefully introduced and allowed to mature for about 60 days, creating delicate blue-green veins and developing a depth of flavor that is both complex and unforgettable. Thanks to modern technology, cheese is produced in compact sizes convenient for consumers. After molding and aging, it is portioned into serving-sized pieces. Finally, an automated packaging system handles the entire process of wrapping, sealing, and labeling, ensuring each piece retains its freshness, flavor, and consistent quality before making its way to consumers. In addition to their rich, creamy milk, certain goat breeds possess another treasure: a cloud-soft coat, most notably the Kashmir goat, native to the frigid mountain regions of Central Asia. On modern farms, they are cared for like top-tier models, with nutrient-rich diets and clean, dry living conditions. These ideal environments allow their fine undercoat to grow thick, smooth, and exceptionally insulating, one of the most coveted raw materials in the luxury fashion industry. It's not just the mother goats. Kids are also nurtured with great care from birth. Every healthy individual represents the perfect continuation of the Kashmir bloodline, where this soft heritage is not only the shimmering fleece itself, but also the result of generations of meticulous breeding and devoted care, where fashion and nature meet in every fiber. In spring, when the fine undercoat begins to shed naturally, mature Kashmir goats are harvested with the utmost gentleness and precision. Skilled handlers use special combs or modern shearing machines to gather each wisp of fleece as light as smoke. Every stroke is performed slowly and carefully, causing no pain, allowing the goat to remain completely comfortable, almost as if enjoying a relaxing spa session before summer arrives. It is a moment where nature and human care blend in perfect harmony. What transforms a bundle of raw goat hair into the refined fabric featured in high-end collections? That journey begins right after harvesting, when each bundle of soft Kashmir fleece is packed into breathable bags and transported to the processing facility, the starting point of a sequence of steps requiring both precision and finesse. At the facility, the fleece enters the first treatment area, where the cleaning process begins. The bundles are loosened either by hand or with specialized machines to detangle and separate the fibers. At the same time, impurities such as leaves, dust, and tiny dry debris are carefully removed. After being fluffed, the fibers move on to an automated washing system, where warm water combined with a gentle solution removes natural oils, sweat, and embedded dirt from each strand without damaging the delicate fiber structure. Immediately afterward, the fibers are dried at a low temperature to preserve their inherent softness, elasticity, and durability, the very qualities that define the unique value of Kashmir. Then the Kashmir fibers move on to the combing stage, where precision machinery gently separates and straightens each delicate strand. Any remaining coarse fibers and impurities are completely removed, leaving behind a uniform layer of soft, lustrous fleece. This is the moment when the pure beauty of cashmere begins to emerge, ready to take the next step in its journey toward becoming exquisite yarns for the luxury fashion industry. The final step in the pre-processing stage is bleaching, a process that evens out the fiber's color, enhancing its aesthetic appeal and increasing its usability in textile production. The finished fibers are then carefully packed into large bales, each weighing between 50 and 70 kilograms. These bales are now ready to be transformed into exquisite threads, then woven into luxurious fabrics, stepping into the world of high fashion, where every humble strand continues its story on the catwalk. From the wind-swept highlands, where goats leisurely graze across vast grasslands, to modern factories where fresh milk is transformed into rich, creamy cheese and fine fibers are woven into exquisite fabrics, the journey of the goat is a symphony between nature and the human hand, crystallizing into flavors and beauty that transcend time. First, the journey of mighty turkeys begins with artificial insemination, a widely used method in turkey farming to increase productivity and ensure reproductive efficiency. This process involves injecting semen into the hen's body using a syringe or specialized equipment, ensuring that the semen reaches the oviduct accurately. This procedure is typically performed 4 days a week, with each turkey being inseminated once a week. Remarkably, workers can inseminate approximately 500 to 600 turkeys per hour, demonstrating the efficiency and high speed of this technique in large-scale farms. This method not only optimizes the production of fertilized eggs, but also saves time and effort compared to natural mating. After artificial insemination, hens are released into a comfortable environment where they are free to choose their nesting boxes. At modern farms in the United States, these nesting boxes are equipped with a smart timer system, an intelligent system designed to optimize egg collection and protection. When a hen lays an egg, the system automatically activates a soft conveyor belt that gently moves the egg out of the nest, minimizing the risk of cracks or damage. Sensors within the system monitor the number, size, and surface quality of the eggs, removing any that do not meet the required standards. The collected eggs are then transported to the incubation area, where they undergo preliminary cleaning before being sorted and placed into industrial incubators. These incubators maintain an ideal temperature of around 37.5 degrees Celsius and humidity levels to ensure the highest hatching success rate. They are also equipped with a mechanism that gently turns or rotates the eggs, mimicking the natural behavior of a mother hen. This process ensures even distribution of heat and moisture while preventing the embryos from sticking to the eggshells. After approximately 30 days in the incubator, the eggs will hatch into healthy chicks. Immediately after hatching, the chicks are transported from the incubator to the sorting area using an automated conveyor system, ensuring safe handling and minimizing stress. This system efficiently moves the chicks into an initial health check process, followed by gender classification performed by skilled professionals. The most common and effective method is vent sexing, which is applied when the chicks meet specific health and size criteria. With a sorting speed of 600 to 1,000 chicks per hour per worker, a single farm can process between 10,000 and 12,000 chicks per hour, ensuring maximum efficiency and precision. Once classified, the chicks are transferred to modern rearing facilities. Here, the chicks are cared for in a tightly controlled environment to ensure optimal growth and development. One of the key features of this modern poultry farming system is the automated feeding system, designed to provide consistent and adequate nutrition to the flock. This system includes automatic feed troughs integrated with conveyor belts or pipelines, ensuring that feed is evenly distributed and delivered on time. Turkeys raised for meat are typically ready for harvest in 16 to 20 weeks, reaching a weight of 8 to 12 kilograms. Once the turkeys reach their optimal growth stages, it's time to transition into the next crucial phase, the harvesting process. When it's time to harvest, advanced transport equipment, like tractor trailers with metal cages, is used to move the turkeys efficiently. These trailers can hold up to 200 to 250 turkeys per cage, allowing for quick and smooth transportation to processing facilities. Once the turkeys are transported to the processing facilities, the next crucial step in the journey begins. Before processing begins, the turkeys are moved into a pre-processing area designed to minimize stress. This area is illuminated with calming blue lights, which help to soothe the birds and reduce agitation. Once the turkeys arrive at the main processing area, the next vital stage in their journey begins. Here, the turkeys are treated with incredible precision and speed. They are carefully suspended by their legs on a conveyor belt, passed through hot water that helps loosen their feathers, and the magic happens. Automated plucking machines step in, swiftly removing every feather with remarkable efficiency. Advanced technology, complete with sensors and automated blades, processes up to 8,000 to 10,000 birds per hour, ensuring flawless operations. Heads, necks, and tails are removed in a smooth automated sequence, leaving only the finest cuts of meat. Next, the turkey birds are swiftly cooled, either through immersion in ice water or air cooling systems, ensuring that their temperature drops quickly to preserve freshness. Once the turkeys are cooled, they enter a rigorous quality control stage to ensure only the highest standards are met. Advanced inspection systems, including high-resolution cameras, sensors, and skilled quality assurance personnel, meticulously check each bird for defects, contamination, or abnormalities. Birds that do not meet the strict quality criteria are immediately flagged and removed from the production line for further assessment or disposal. Now the turkeys are ready for the final step. They are expertly cut into prime cuts, breasts, thighs, wings, or kept whole for packaging. The finished products are then carefully packaged, labeled, and prepared for shipment. This highly efficient process is designed to minimize waste, optimize productivity, and meet the highest food safety standards, ensuring only the best quality turkeys reach your table. Beyond whole and cut turkey meat, further processing transforms this versatile protein into a variety of convenient and delicious products, such as turkey nuggets, turkey sausages, and other ready-to-cook items, offering even greater options for consumers. Backed by massive, state-of-the-art production lines, a staggering 6.2 billion pounds of turkey flood the market each year, ensuring lavish feasts for every celebration. After going through the meticulous processing at the factory, the journey of the turkey continues, extending beyond the production line, becoming a symbol of tradition, family, and togetherness. From the legendary Thanksgiving feast to the cozy atmosphere of Christmas, turkey is always a vital part, bringing joy and unity to every family. Nothing symbolizes gratitude and family reunion like a golden, perfectly roasted turkey with crispy skin and tender, juicy meat, proudly placed at the center of the Thanksgiving table. Similarly, on Christmas Eve when families gather, A turkey shimmering in the candlelight is not just the main dish, but a symbol of love, sharing, and the bond that connects loved ones in a warm, heartfelt setting. Beyond special occasions, turkey is a staple in everyday meals, valued for its high protein and low-fat content. From deli sandwiches and salads to tacos, turkey effortlessly adds fresh flavors and nutrition, making it a versatile choice for wholesome family dishes.